Hello everyone, in this presentation we are going to understand how to interface a 16x2 LCD with a microcontroller. So what you see here in the screen is a text display. You are able to see welcome to Freescale Lab. So here if you have to observe if you observe carefully, so there is one hyphen and there are two less than symbol, then welcome is all uppercase letters and the TO is a lowercase letter you have to notify, and then two greater than symbol and another you have an hyphen, then a quote, the double quotes are there, then the Freescale Lab is in between Freescale and lab there is a blank space, and then the double quote is ending, and then finally it is very important you are able to see the exclamation mark. So the uppercase letters, lowercase letters, special symbols, and exclamation mark is a special symbol. So all the ASCII characters or all the alphanumerical characters can be displayed with the help of 16x2 LCD display. That is being justified or that is being understood in this screen. So this LCD is it itself is an embedded system which accepts the ASCII values. Say for example, it accepts the ASCII values means what? The ASCII equivalent of W is given means it will display W. As we all know, all the alphanumerical characters can be displayed effectively in the humor readable format only with the help of 5x7 matrix. So this is a 16x2 LCD display. This 16x2 LCD display, each segment, so there are 32 segments, 16 segments in the first row, another 16 segment in the second row. So each segment is a 5x7 matrix. So there are 35 pixels are there. So 5x7 means 35 pixels are there to display each alphanumerical character. So there is a big intelligence available in this LCD, 16x2 LCD. So the only requirement is we have to send the ASCII value. So it will convert into ASCII values into its equivalent ASCII format and then display like our computer screen. Okay, so this is the one you need to understand. So this LCD display is connected to the microcontroller. As you see here, this is the 8051 development board. In this 8051 development board, we have connected this LCD. So as we see here, so it is a parallel data transfer. So the port 1 of 8051 microcontroller, as you see here, the port 1 of this 8051 microcontroller is connected with the LCD data lines. So the LCD accepts 8-bit data. So the 8-bit data line of this LCD is connected to port 1. So through port 1 the data comes out, all the ASCII data comes out and then it displays. So there are three control signals. There are three control lines for this LCD as we know very well. So there is a register select, read write and enable. The register select pin is connected to P2.0 and the read write pin is connected to P2.1 and then enable pin is connected to P2.2. So 8 plus 3. So 11 GPIO lines are necessary from the microcontroller to interface a 16x2 LCD as we see here in this board. So now if you look at the circuit diagram, so I can able to see the circuit diagram here. So if you look at the circuit diagram, so this is the circuit diagram for the LCD display interface with respect to this development board. So if you look at here, so in this connector 14, if you observe carefully, so there are BRK11 connector which contains 16 pin. So there are BRK11 connector which contains 16 pin. So as we all know, with respect to the LCD, the first pin is ground, second pin is VCC and the third pin is so the connector pin, that is contrast adjustment pin. CON means contrast adjustment pin. So there is a potentiometer which is connected here. As you see here, there is a potentiometer which is connected here. So this potentiometer knob can be adjusted to vary the contrast. So the first pin is ground, as you see here, the second pin is VCC. So in between the first and second pin you have a potentiometer. The potentiometer output is connected to the third pin, which helps us to adjust the contrast of the 16x2 LCD. We'll see that in the hardware. So this potentiometer is here. So in this development board, this potentiometer is here. So when we adjust this potentiometer, you can observe the contrast variation in the LCD display. If you see here, now I am rotating in clockwise direction, the LCD is not displaying anything. So when I rotate in the anti-clockwise direction, you're able to see slowly the corresponding segments are getting displayed, you see. So when I keep on rotating in the anti-clockwise direction, you can able to see the blank screen. So black screen. So by adjusting this potentiometer, we can adjust the contrast of this particular 16x2 LCD. So this potentiometer is the potentiometer what we have seen in this circuit diagram. So after that, this register select pin. So this is the register select pin. This register select pin is to select whether the address is coming in this data line or whether the data is coming in this data line. As we all know, the first row of the LCD address is 80 to 8F. The second row of the LCD's address is C0 to CF. What does it mean? If you give C0 means second row first column is the place chosen to display the number. Okay, so for that, if we have to send the register select pin as 0 to send the command. To send the data, we have to make the register select as 1. So differentiate whether the data is coming through the data line or whether the command is coming through the data line. We are using this register select pin in the LCD, and there is a possibility for us to read as well as write. So there is a read write pin, and then when you give the enable, then LCD will accept the data available in the data lines. Okay, so these register select, read write and enable pin are the control signals, and then D0 to D7 is the data 8-bit data signals. Okay, so there is something like backlight plus and backlight minus, which we are not using here in this circuit diagram. So this is the circuit diagram to interface a 16x2 LCD with the microcontroller development board what we have with us. So after connecting the circuits as per the discussion, so we are supposed to write the code, and if you look at the code, it's very interesting. As we see here, the code starts with hash include reg51.h. as we know very well, the code starts with hash include reg51.h, and the register select pin of the LCD is connected to P2.0, the read rate is connected to P2.1, and the enable pin is connected to P2.2. So these three are the control signals of the LCD, which is connected to microcontrollers port pin P2.0, 2.1 and 2.2, and as usual we have a small delay routine, delay function here. And to differentiate whether it is a command or data, we have two functions. So to command, for the command we have this function as discussed right now. For sending the command, if you observe carefully, the register select pin is 0, and for sending the data, you can see the register select pin is 1. So the rest, so this is the command, so the rest of the thing is same. So to the port 1 we are giving the value and then making register select as 0 and read rate as 0, and then enable as 1 and then enable as 0. So when you look at the data, so port 1 is given the data, and then by keeping the register select 1. So one thing you need to understand, there are two functions here. By keeping register select as 0 and giving port 1 value means you are giving the command to the LCD. By making register select as 1 and giving some value to port 1 means we are giving the data. Data means what? The ASCII equivalent of the corresponding code. When you want to display A means we have to send 41. So 41 through port 1 means ASCII equivalent of the alphanumerical character A, capital A is 41 hexadecimal value. If you send it through the port 1 and then you make RS equal to 1 means, so the LCD display will display A in the corresponding location. Okay, so that is what we need to understand. So after say for example when you are giving the command means what? When this function is being called, the value will be given to port 1 and then making RS as 0 and then rew at 0. When you give enable 1 and then, so there is a transition from 1 to 0 in the enable. So making enable as 1 and then making it as 0, LCD will accept this command. Similarly, when you are sending any data, by making all the control signals RS as 1 and RW as 0, because 0 means writing, we are writing into LCD. When RW is 1 means we are reading from the LCD. Okay, so now we are writing into LCD, that's why RW equal to 0. So these two are the control signals and this is the data. P1 is the data. So the data and the control signals will be accepted by the LCD only when we give the enable signal from transition from 1 to 0. So these two are the functions for data and command. So when coming to the main function, first we are giving the command. So what is the command? The first command is we are initializing the LCD by sending the hexadecimal value 0x38. 0x38 is what? To notify that it is 2 lines 5x7 matrix. As discussed, 5x7 matrix is the matrix which can help us to display all the alphanumerical characters. So each segment, that means the first row 16 segments, second row 16 segment. So all the 32 segments are 5x7 matrix. So 35 pixels for every segment. So to notify that, we have to send this first command, LCD command at 38. So the second command is 0E. So 0x0e means what? So you are switching on the display and then you are making the cursor to blink. So this is the control signal as per the 16x2 LCD template. And when you give 0x01 means it is clearing the display screen. So when you give 01 means it will clear the screen. And then 06 means increment cursor. What do you mean by increment cursor? Now we are giving the as discussed if you see here, when you give the command as 80 means what? It notifies, the command is 80 means address of the first row first column. Address of the first row first column is 80. Because we have given the command as 06, after giving 80, when you send the data as to the 80th location, automatically the address will increment to 81 to display the second data. After putting the second data, the address will increment to 82 to display the third data. So the address will automatically increment. To make this address to increment automatically, to increment after the data is given, we have to give the command as 06. So if you give 06 means it will automatically increment the address. Say for example, otherwise if you are not giving 06 means what? We have to give 80 command and then we have to give the underscore hyphen data, and then we have to give LCD command 81 and then we have to give the less than symbol, then 82 and another less than symbol, 83 and then W. Instead of that, if you give 06 means it is a convenience, something like how program counters keep on incrementing. Similarly, this address will keep on increment from 80 to 8F based on the data what we give. So all the initialization must happen only once. That's why it is given in the void main, in between the void main and while one. But this content has to be repeated. That's why we are putting inside the while one loop. So the first line is LCD command 80 means first row first column is chosen, and then in the first row first column what need to be displayed? Hyphen need to be displayed. First row second column less than symbol, first row third column another less than symbol. Then similarly WELCOME, one blank space, and then 2O, TO2. So these two, TO2 is a small letter, and then 2 greater than symbol, and then some hyphen. So as we all know very well, in the C syntax, within a single quote, it's very important, as we all know very well, with respect to the C syntax, within a single quote, what character that we will give, its ASCII equivalent will be transmitted to the port 1. So LCD data is a function. LCD data is a function where the ASCII equivalent of the W will go here to this DAT variable, and then this DAT, which is the ASCII equivalent of W, will be transferred to port 1, which will display W in the 16x2 LCD display. As we all know, with respect to C syntax, for the user's convenience, because it is a high level language, so within a single quote if we give the corresponding alphanumerical character, it will send the corresponding ASCII value through the data line, as we all know very well. So similarly, the first row, it will display welcome to uppercase, lowercase, special symbols, etc. And then we are giving the command as C0. What do you mean by C0? Second row first column address. Second row first column address of the 16x2 LCD is C0. After giving C0, in the second row we are displaying the content, first double quotes, then followed by Freescale Lab. So because this video is taken in the Freescale Lab, that's why we are giving it as Freescale Lab. And then finally, we are able to put an exclamation mark to say that yes, all the special symbols can also be displayed in this, and this is getting repeated continuously in this while loop. So that is why welcome to Freescale Laboratory is being displayed in the screen as we see here. So if you look at the screen here, you are able to see here welcome to Freescale Laboratory. If you want to change something, I can change a few things here. Let us say welcome to Freescale Laboratory means welcome to, I am changing it as some embedded means what? I am changing it as embedded means what? I can change capital E, and then you can say embedded means EM, and then B, E already is there, EM, B, D, D you have to put D, embedded, EM, B, D, D, E, D, embedded lab. If you want to change it as embedded lab means what? Just like that we can change it That's all. It's very well, you can do it as per our convenience. So after writing this is embedded, I hope you are able to see the second row. The second row you have changed this welcome to embedded lab. So after this we are compiling and building the code, and then we are downloading it through this Nuvoton. So we are giving the upload chip. So data is going inside. Now you see here. So right now it is displaying welcome to Freescale lab. Right now it is displaying welcome to Freescale lab. But when you download it, we are able to see that welcome to embedded lab. When you download it, we can able to see that welcome to embedded lab. So let me download this. So after building, we are downloading this code through Nuvoton. So we are giving the update chip. So it is getting downloaded. Now I am pressing the reset button. So if you observe carefully, we are able to see welcome to embedded lab. You are able to see welcome to embedded lab. You are able to see welcome to embedded lab. So like this, as per our convenience, we can able to change. So the one thing I want to mention here is, so this presentation says that how to interface 16x2 LCD with microcontroller is being discussed. This can be customized for n number of applications. So for example, this coin box, earlier we used to work with coin box. The coin box earns money by itself with the help of this 16x2 LCD, because it will, whenever you receive when the receiver is taken, it will say insert coin. After inserting the coin, it will display dial the number. Then we will dial the number will get displayed. After the receiver caller have taken the handset, means it will decrement the seconds count. Like that, this 16x2 LCD display can be customized for n number of applications. So this presentation is just an inauguration how to understand how to interface 16x2 LCD display with a microcontroller. So you can make it as a scrolling display. We can make it as in so many ways we can do it. So many control signals are there. In the following video presentations, we will discuss all the features of the 16x2 LCD. Thank you very much.